Hello everyone. Good evening. Siddhant, Vaishnavi, Anvita, Upasna, Aditi, Aditya, Shrikant, Miss Kaur, Vaishnavi. So I hope you are in the full form for CAT 2024. Right? Swapnil, Vabhavi, I welcome you all. A very good evening. Hello Petrus. So today's agenda is geometry. We are going to discuss about types of triangles and its properties. But before that, any comments from your side? How is your preparation going on? Is it fine? Yes, please contact our iQuanta team. They will give you exact detail for that. And these master classes are the basic classes for last batch specifically. Although it is common to all, for our past students of past batches, as well as new students or the students who have not yet joined iQuanta. It's for them as well. So please get in contact with our iQuanta team. They will give you the exact details for that. Someday good, someday bad, Vaishnavi thinks. Okay, good, nice. So it means sometimes you are able to solve questions, sometimes you are able to get a good score in mock test, sometimes may not be, isn't it? Aditya, kal mock mein bahut kam marks aaye. Yes, it may happen. So don't judge yourself by the marks of any mock, isn't it? Are Baba, you should not judge yourself by the marks of even CAT. Even CAT cannot define you. So please don't worry. So just take these as the reminders. Whatever setbacks you are going to face, you are facing presently also, just take them as a reminder for yourself that you need to work harder. Isn't it? You need to work harder. Janardhan, yes, in last batch also all the classes are going to be there. We are not going to cover the whole topic of geometry or triangles. There are going to be a lot more things. It is just basis of that, just basics of that. Miss Kaur is facing difficulties in LRDI. LRDI se to sabki hai ladai. And don't worry, Miss Kaur. You just need to pick up the right questions, right sets, and attempt them with accuracy. That is the only thing which is required, isn't it? Specifically for LRDI section, there are going to be 4 sets normally. So in those 4 sets, you need to pick the best one, right? So for that purpose, you need to go through all the sets and try to understand what is given, what is being asked, and how to proceed to find out the required things. And then accordingly choose your set where you are going to invest your time and efforts. Fine? All those students who are asking about when your last batch is starting, so I have already answered that. Please contact our iQuanta team. I'm your servant here. I just being informed that you are to take up this class, and I'm here for that. Fine. So I'm taking classes in multiple batches and many different ways. So please contact your iQuanta team for the exact details regarding your last batch. Okay, let's start now. Yes, Jayant, right. Do we not have trigonometry for CAT? It was missing from the syllabus. Trigonometry is not a part of CAT geometry specifically. There are few things related to trigonometry which are generally taught and which are generally useful for your geometry part, and that we are going to discuss today as well, right? So, but as such, trigonometry is not a part of your CAT geometry. Trigonometry and your coordinate geometry, what else? That's it, these 2 things. So these 2 things are just to touch. If you are aware about them, just basics of them, they can be useful at times. But as such, there are no direct questions based on trigonometry only or coordinate geometry only. They may be used, but if you have your basics clear, then you can solve all the questions. Fine. So let's start now. No problem, Ria. As I said already, that all these setbacks are reminders for you that you need to work harder. So please find out the areas of improvement and work on them. Okay, so let's start now. Yes, let's start now. Let's start. So we are going to discuss about types of triangles and its properties. So same in the previous batches we have already discussed about them, and those who are attending the geometry class for the first time, you also have studied about triangles in your school level, right? So in CAT for geometry, I will certainly recommend. I have recommended it earlier as well, that it is highly beneficial to go through 6th to 10th class NCERT books, specifically for geometry. The complete geometry part, the theory part, as well as the questions, you will find the best variety of questions and almost all the concepts which are being used in CAT, and some of the questions has been taken from exact NCERT books as well. So if you are not good at basics in your geometry part, refer to these books, and if you are good, then also it is a good practice material to begin with at least. Fine. And after that, of course, the previous year's questions is the best resource, and you are going to get enough study material here also for practice. Okay. Pratham Dwivedi ji, आपका question नहीं answer कर रहे. This question, sir, this session will be free. You are attending it, Pratham, right? So yes, it is. It is. You have not paid anything, I guess. That's why you're asking this. So still you are able to attend. Yes, this session is free for everyone, and it will be available. It will remain here in YouTube. You can watch it later as well. Okay, so let's start now. Let me read one more comment. Paras says, sir, मैंने अभी तक first mock attempt नहीं किया. So please refer to again our iQuanta team for that. कि कब तक attempt कर सकते हैं and so on. अभी मैं attempt करूं क्या? Yes, no harm in that. You will get at least idea that where do you stand and how much you need to work. DILR suggestion, practice, nothing else. In DILR, there is no syllabus, so every question is a new question. So luckily, if you get a familiar question, that will be your first pick, isn't it? And if all the questions, all the variety is a new one, so take your chance. You need to decide then only that which set to start with. Paras, I have answered yours also. Fine. Okay. I have already answered that, Pratyush. So there are many students who are asking about batch 3. So I will again, last time I'm telling that, please contact your iQuanta team. Okay, so let's start now. So we are discussing about triangles. So quickly, you need to be interactive as much as you will answer my queries, my questions. Then that's how we'll be able to proceed faster. So what are triangles? What do you mean by triangle? What do you know about a triangle? Please write in the comments. Triangle के बारे में क्या क्या जानते हो? Please write. What do you know about a triangle? What is a triangle? It's a closed figure formed from 3 sides. Fine, there are 3 sides. So it's a closed figure formed from 3 sides. One thing, what else? What else? Triangle has 3 sides, fine. Anything else? Of course, 3 angles, right? 3 angles and 3 vertices. So 3 angles, 3 vertices, 3 sides. Isn't it? Nice. Okay, sum of all the angles. Yes, thank you, Krypton. So sum of all the angles, let's call them A, B, C. So A, B, C are the 3 vertices. So angle A, angle B, C. So sum of the 3 angles, that is angle A plus angle B plus angle C equals 180 degree. It is called angle sum property of a triangle. Fine. What else? What else? Okay, you are talking about types of triangles as well. Cheek baat hai. Nice. Exterior angle, externally, good. Prashant Raj is talking about external angle or exterior angle basically. So exterior angle sum is 360 degree. See, first we need to know what is the meaning of exterior angle. So exterior angle, as interior angles were formed inside the triangle, between any two sides, the angle inside the triangle is known as interior angle. Similarly, exterior angle is also angle between any two sides, but one of the side is to be extended. Fine. So that means, let's say if I extend this BA, so up to let's say A dash. So this BA extended and this AC unextended. So the angle between them, this is known as exterior angle at the vertex A. Is it not? I repeat. So when I extend this side BA to A dash, so now angle between this extended side and this AC unextended. So this angle is known as exterior angle or external angle also we can say. So what is the property regarding that? You can see that interior plus exterior always add up to 180 degree, right? Interior angle plus exterior angle always add up to 180 degree. And that is true for all polygons basically, chahe wo triangle ho or it may be some other polygon as well. But now there's one important property. If I draw all exterior angles of a triangle like this is first one and this second one, and similarly I'm extending this CB, so then this third one. So all these exterior angles, let's call them angle 1, 2 and 3. So what is sum of these three angles? Angle 1 plus angle 2 plus angle 3. How much this will be? Please answer this. Yes, Pythagoras theorem is also there. We will come to that. What about the sum of these three angles? Angle 1 plus angle 2 plus angle 3. These are all exterior angles. Angle 1, angle 2 and angle 3. These are exterior angles at the three vertices. Yes, it is 360 degree. That's correct, Sri Lalita. This is 360 degree. So sum of all exterior angles of a triangle is 360 degree. And again, this property is also valid for all the polygons. I repeat. See, I talked earlier that sum of an interior angle and an exterior angle at any of the vertex is always going to be 180 degree. This is also true for all polygons. And similarly, sum of all the exterior angles is equal to 360 degree. And that is also true for all the polygons, of course, including triangles, for all polygons. Is it okay? So that is just little bit basic information about triangles, and many more properties you have already mentioned in the comments. Okay, let's proceed further now. There are three sides in a triangle. Can any three sides make a triangle? Let's discuss about some properties of triangle. So what is the condition on the sides of the triangle? Which sides can be used to make a triangle? Is there any condition? Yes, there is a condition which is known as triangle inequality. The condition is known as triangle inequality. What is that? Can anyone tell me? Yes, good, Ridhima. Sum of two sides is more than third side. Nice. So sum of any two sides should be more than the third side. Okay, anything better than this? Ridhima has already mentioned this triangle inequality. That is perfectly fine. Anything better than this? Can you think of? No? Difference of any two sides is less than third side. That's nice, Aditya. Good. So difference of any two sides. So difference of any two sides must be less than the third side. Okay? So sum of any two sides must be more than the third side, and difference of any two sides must be less than the third side. That's perfectly fine. Good. Thank you, Usha. Nice. So longest side must be smaller than sum of other sides. So that is the best way or shortest version of triangle inequality. We can say that longest side must be smaller than sum of all other sides. So this is the shortest version of triangle inequality, and again this is valid for all polygons. This is valid for all polygons, of course including triangles. Okay? Is it okay? Let's apply this. Good, Vidya, that's true. Angle opposite to larger side is larger than the angle opposite to smaller sides. And don't forget to use the phrase in a triangle with this, Vidya. So, अगर हम एक ही triangle की बात कर रहे हैं, in a triangle, so there are two angles, one is larger than the other. So the side opposite to the larger angle would be larger than opposite to the smaller angle. Fine. And this is vice versa. We can talk about sides also. If in a triangle, one side is longer than the other one, there is a longer side and other one is a shorter one. So if this is a triangle, so in this triangle, this is longer side than this one. So angle opposite to the larger side or longer side will be larger than the angle opposite to shorter side. Okay? So in a triangle, we cannot compare two different triangles with this property. Fine. It may be possible that angle opposite to this side length is smaller than angle opposite to this side length in some other triangle. Right? There can be different triangles. Na? There could be some other triangle. Let me make it here only. So if this is one triangle, triangle ABC. Okay? And let me draw another triangle. Something like this. Triangle ADC. Now my question is, if I ask you, what about angle C, that means this angle ACB basically, let me write completely, angle ACB and angle ADC. Angle ADC. What do you think? Which would be larger? Which would be larger? Angle ACB and angle ADC. Which would be larger? Can we say something? See, angle ACB is opposite to AB and angle ADC is opposite to AC in this triangle, right? And it is clearly visible that AB is more than AC. Let me give this. It is mentioned AB is more than AC. Now, can we say something about these two angles? Please think and answer this. Angle ACB and angle ADC. Which of these two angles would be larger? It is mentioned that AB is more than AC. Can we say something about this? No, yes. We cannot say anything. Why? Answer is that we cannot say anything. Some of you are writing ACB or some ADC. So ACB or ADC, out of these two, which angle is larger? We cannot comment anything. Why we cannot comment? You still are writing, you still are thinking one of them is greater. No, don't go by the diagram. See what are the given conditions. We know that AB is more than AC. But how much more? We don't know. What about AD and DC? Don't know. So we cannot comment anything just based on the basis of this information, because these two angles are in the different triangles. They are in different triangles. Yes, they are not relatable. We cannot relate them. ठीक है ना? So don't think that AB is more than AC. So AB के opposite angle would be larger than AC के opposite. But AC के opposite, that angle ADC is in the different triangle. It is not in the same triangle. So only for that purpose, as a statement made by Vidya, I commented earlier also. So please make sure. So whenever we are saying that angle opposite to larger side is larger and shorter side is shorter, with that there is an important phrase that in a triangle, in same triangle basically. In two different triangles, we cannot say that. Okay? Yes, these are two different triangles. Yes, that's true, Gayatri. Got it, everyone? Understood? See, my only purpose is that your concepts must be as clear as possible. Learning formulae is not difficult. But when to apply what, if you are not clear about that, then everything is a farce, failure. Okay, good. Okay, so let's continue. So we were talking about this triangle inequality. So longest side should be smaller than sum of others. So that is the shortest version of triangle inequality, and it is valid for all polygons, as I have already mentioned, that if it be a quadrilateral, pentagon and so on, then also it is valid. But mostly in our CAT section, we are talking about triangles only. That's why we use it in triangles only normally. But for others also, this inequality can be used, that longest side it should be smaller than sum of others. That's it. Okay, let's say if two side lengths are given, can we find out the third side length? Yes, why not? कर सकते हैं ना, find out. Okay, let me ask you a question. I think here it is. Yes, here it is a question. Please answer this. A triangle has its sides as 5, 9 and x. How many integral values of x are possible? Please answer this. Yes, Anvita, angle ADC should be checked in triangle ACD. Yes, they are two different triangles, na? That's why we cannot comment anything there. Fine, now let's answer this. Okay, let's go, Siddhanshu. No need to repeat your answer, let's go. In CAT, you don't have extra points for answering faster, you know. There are no extra points if you answer faster. I have also been of that aptitude always, that I want you to answer fast every time. But gradually I have learned that answering faster is good, but even good is that answering correctly with accuracy. So accuracy is of much more importance than your speed. Fine, and that is your keywords for your mocks as well. Right, so accuracy, always prioritize accuracy over speed. Okay, a triangle has sides 5, 9 and x. How many integral values of x are possible? Most of you are answering 9. In between I can see few different answers as well. I think Riddhima has mentioned 13 and Gummala or Srinath something is mentioning 12. Okay, Chintan 89 kahan se aa gaya bhai? I think you are saying 8 or 9. Okay, let's see how to do it. So it is just on the basis of that triangle inequality which we discussed earlier. So we saw there, I didn't give you any reason for that, by the way. Anyway, that's a true thing. So you all know that. So triangle has its sides 5, 9 and x. So how many triangles, how many integral values of x are possible for the third side length, right? For x. So two sides are known to us. What about third side? So as we discussed earlier in the previous slide, that the third side x should be the sum of any two sides must be greater than third side. That means this 9 plus 5 should be more than x, and also difference of two sides should be smaller than, difference of two sides must be smaller than this third side, right? So directly if I apply this, so I get this range, that's it. So this x, let me revert it, so invert it, so x should be smaller than 14 and greater than 4, isn't it? So the minimum value possible for x is 5. So x minimum can be 5 because it needs to be an integer. We are looking for the integral values here. So minimum value possible for x is 5 and the maximum value possible is 13. So a simple counting question now. You just need to count from 5 to 13 how many integers are there, isn't it? Yes, it should be smaller than 14 and more than 4. So we just need to count now that from 5 to 13 how many integers are there. Now it's up to you. You can count on fingers 5, 6, 7, 8, 9, 10, 11, 12, 13. That's it. So 9 values. Or you could have counted like this also, that from 1 to 13 there are 13 values, isn't it? No need to count on fingers now. But I need to start my counting from 5. That means I need to leave the earlier 4 values. So 13 minus 4, that gives you 9. So this is our answer. Fine. So 9 is the right answer and most of you answered it correctly. That's good. So please don't do mistake in counting. Some of you mentioned, I think 13 as well. So 13 is the maximum possible value. But this is not the only value, or these much values are not possible. The minimum value x can take here is 5. Is it okay? Is it okay to everyone? Krypton, it can be equal to 13 as well, not smaller than 13. It can be equal to 13 as well. That's true. Aditya, 13 minus 5 plus 1, but that is not required. 13 minus 4 is better, na? Okay. Prashant is asking why 9 minus 5? 9 minus 5, I didn't say anything. Acha, here it is. Okay, we discussed in the last slide there that the sum of two sides must be more than third side, and the difference of two sides is smaller than third side. That's why I've used it directly. Otherwise, I also mentioned, if you remember, the shortest version was that longest side must be smaller than sum of others, right? That is sufficient. So out of these three, please answer me now. We have already solved this question. We have got our answer also. I'm discussing again. Now listen carefully. Listen carefully and tell me, out of 5, 9 and x, which of the three can be the longest side? Please answer. Which of the three can be the longest side? Yes, excellent, Adarsh. Good. So either 9 is the longest side or x is the longest side. 5 can never be the longest side because 5 se zyada to 9 hai hi, right? So either 9 is the longest side or x is the longest side. And I told you the condition that longest side must be smaller than sum of all other sides. Fine. So if 9 is the longest side, in that case this 9 must be smaller than sum of others, that is x plus 5. That is one condition possible, which tells us that x must be greater than 9 minus 5, or x must be greater than 4, or x must be greater than or equal to 5. Is it not? So if 9 is the longest side, if 9 is not the longest side, in that case x must be the longest side. So longest side, yani ki x must be smaller than sum of others, that is 9 plus 5. Which gives you that x must be smaller than 14 or x must be smaller than or equal to 13. That means x should be 5 or more and 13 or less. So x varies from 5 to 13. That's it. So same thing we had done already here. Okay. So there can be various ways to think. Clear? Good. Okay. Before I move further, let me ask you one more question then. I'm asking you one more question. A triangle has all integer sides, integral side lengths. Fine. It means that all the sides have integral length. Okay. And a triangle has all integral side lengths. If the perimeter of the triangle is 10, then how many such different triangles are possible? Please answer it fast. I'm reading it out for you again. It says a triangle has all integer side lengths. If the perimeter of the triangle is 10, then how many such different triangles are possible? Different means which cannot be overlapped, which are non-congruent basically. Fine. Different means which are not congruent. Non-congruent. Okay, answer it fast. Chintan says 2 distinct triangles only. Okay. Let me hear from others as well. Okay, you are using some shortcut, p square by 48. Which two triangles, Chintan? Can you mention the sides? See, CAT is not dependent on shortcuts. Shortcuts may help us sometimes to get the answer faster, but conceptual clarity is much more important. Okay, Swapnil, Petrus, let's go, Mehak, Shruti, Prakhar. Most of you are saying 2. In between, I can say a few 3 also. Calm and relaxing says 3. Oh, who else is Madhav? Thought Kare something is saying 3. Siddhanshu, 8. 8 तो बहुत ज़्यादा हो गया भाई. 8 is I think too much. Okay, Chintan, 2, 4, 4 is one such triangle. ठीक है. Okay, how to count this? Most of you are although saying 2 and 2 is the right answer by the way. That's correct. Monish, 3, 3, 4 and 2, 4, 4. Chintan, it is not 3, 3, 5, it is 3, 3, 4. Right, these are the 2 triangles possible. How are you sure that no more triangles are possible, that these are the only 2? How you can be sure about that? Any comments for that? How you are sure that these are the only possible, these are the only 2 possible triangles, nothing else? These 2 are fine. 2, 4, 4 and 3, 3, 4. Right, Sriram, that's true. 3, 3, 4 and 2, 4, 4. That's fine. But how are you sure that these are the only 2? Nothing else is possible. How you are sure about that? That's my question now. Because the moment I'm going to increase it from 10 to 100, the value is going to increase drastically. Isn't it? Inequality. Okay, good. Yes, we need to follow the same property which we were discussing. Okay, let's check that. So in the previous slide, we discussed about that longest side. Let's say the 3 side lengths are A, B and C. Assuming that they are in the increasing or non-decreasing order basically. So A is greater than or equal to B, which is greater than or equal to C. So among them, the longest side could be C only, fine. So as I discussed, that longest side should be smaller than sum of others. So that is sufficient. If this is the case, then we can easily say that triangle is possible. Okay, if C is the longest side, then it must be certainly smaller than the sum of other 2 sides. Now, if I add let's say C both sides, C is the longest side here. If I add C both sides, add C here, so add C here as well, right? And now this A plus B plus C is nothing but perimeter. That tells you that 2C is less than perimeter, or C, the longest side, must be less than half of perimeter. That's an important result. That's an important conclusion from here, that longest side of a triangle must certainly be less than half of the perimeter. And because it is longest, so it cannot be smaller than any of the other. Maximum, at max, it can be equal to the other sides. Fine. So let's come back to here. So here perimeter is 10. So what is the maximum possible length of the longest side? Remember, it should be smaller than half of perimeter. So half of perimeter here is 5. So it must be smaller than 5. So maximum it can be 4. So the longest side can be maximum 4. Fine. Can it be 3 also? If I keep the longest side less than this, that is 3, then other 2 sides cannot be more than 3. So the perimeter could not become 10 in that case. So longest side has to be 4 in this case, right? Nothing more than that, nothing else. So if the longest side is 4, now other 2 sides can be anything, not more than 4 of course. So the maximum can become equal to 4. So if second longest side is 4 only, then third side becomes 2 because the perimeter had to be 10. That is one case you already mentioned here. And similarly, keeping the longest side to be 4, second longest side can be less than 4, maybe 3. In that case, the third side remains 3 only. So 4, 3, 3 was the other case. Fine. And if I go further lower than this, in that case, I'm just going to repeat the value. So second longest side should also not be smaller than the third side. So that's how I can, without making any repetition, I can count all the cases. ठीक है ना? Okay, quickly answer the same question. If I just make it 18, can you tell me the maximum possible length of the longest side, please? Maximum possible length of the longest side. जल्दी से बताइए. Fast. Yes, maximum possible length is 8, right? Because 18 is a perimeter, then 9 से कम होना चाहिए. So maximum possible length for the longest side is 8. And what about the minimum possible length for the longest side in this case? That's too wonderful. What about minimum possible length? Minimum possible length for the longest side. Keeping this as 8, we can count all the cases. That's fine. But now I'm asking, what about the minimum possible length of the longest side in this case when parameter is 18? Siddhanshu, it cannot be 2. I'm talking about the minimum possible length of the longest side. Longest side only. Mind that longest side cannot be smaller than the other two sides, na? Not 7, not 2, not 2. Yes, 6 is correct. Are Baba, don't forget that. I'm repeating. Please listen carefully. The longest side is to be, as I mentioned here, the longest side cannot be smaller than the other sides. At max, it can become equal to them. So the longest side would be smallest if all the three sides are equal. So in this case, the longest side, minimum possible value for the longest side would be 6. Right, 6. ठीक है ना? So I need to count when the longest side is 8 to get all the cases, and when the longest side is 7, and when the longest side is 6. So these are the three things, three cases we need to count. So let's start from here only. I need to count the total numbers of such triangles. So when the longest side is 8, then the second longest side maximum, it can be equal to 8 only. So 8, 8, 2, then 7, 1, then 7, 3. Just decrease this by 1 and increase this by 1. 6, 4, and 5, 5, isn't it? So with 8, 8, these are the four triangles. After that, keeping the longest side to be 8, second longest side can be 7, right? Now 8, 7, 15, and this is 3. So I'm starting with 7, 3. That is done already, now. Oh, these all cases are done now. So 8 wale, all cases are done. 8 wale, all cases are done. Now we need to count the cases with 7 as the longest side. With 7 as the longest side, the second longest side could be equal to 7 only, right? 7, 7. After 7, I need to distribute 11 further because perimeter is 18. So 7 and 4, that will make a triangle. Then 6 and 5. That's it. Fine. So all cases with 7 as the longest side are also done. And with 6 as the longest side, there's only one case, that is 6, 6 and 6. That's it. So 4, 2 and 1. So total 7 such triangles are there. Is it fine? Is it clear to everyone? So whatever question being asked, we can easily count that. It's not a difficult thing. Okay. So I'm trying to discuss all those things which should be beneficial for the past student, previous student as well, if you are practiced somehow, and for those as well who are new totally. ठीक है? Okay. Before moving further, let me ask you one more question. Let me ask you one more question. Is there any doubt in this? Riddhima is asking 634. 634 perimeter doesn't become 18, na, Riddhima? ठीक है? Okay, before to move further, let me ask you one more question. I'm erasing this. Now, question is, there are 10 sticks. Now, this is a good question. Everyone, please be very careful and answer. Calm and relaxing, one of the side is to be largest. Now, I assume C to be the largest. That's it. Yes, good question, Haripriya. Haripriya is asking that how did you decide that minimum possible value for the longest side? Now, please everyone, look here carefully. ध्यान से बात समझिए. We know that there are three side lengths A, B and C. ठीक है? A, B and C. I assume that C to be the longest side and B या तो उसके equal होगा या उससे छोटा होगा and C या तो उसके equal होगा या छोटा होगा. Fine so far? Fine so far? R sheet is not required. Some of the students mentioned the shortcut to get the answer. But you are an old student, I guess. So I generally prefer to disregard the shortcuts. I don't prefer to use shortcuts because exam is not going to check whether you know the shortcut or not. No, exam is going to check whether you can use your intelligence or not. ठीक है ना? Anyway, come back to this point. The question here is how to decide what can be the minimum possible length of the longest side. So C being the longest, B उसके equal या उससे छोटा हो सकता है, and A can be again equal to B or further less than that. So now, what is given in the question? We know the perimeter, right? Perimeter is constant. So in the last question, perimeter was 18. That means sum of the lengths of A plus B plus C, that is 18. ठीक है? Now tell me, if I decrease the length of C, so length of B and length of A must increase? Yes or no? Yes. But I know that C cannot go less than any of A or B. So the moment I'm decreasing the value of C, the values of A and B are increasing. Yes or no? Yes. So what is the lowest extent to which the C can be shortened? C को कितना कम कर पाएंगे? Please think and answer. Yes, excellent. Yes, exactly, Chintan. That's true. Whatever be the parameter, it may be multiple of 3, it may not be. It's okay, no need. Yes, we can count that. And manually, individually also, if you will count, you will always see a pattern there. Is it okay? If 18 is a parameter, so the moment I decrease the value of C, A and B are going to increase because the parameter is to be constant. So what is the extreme extent to which C can be decreased? So the lowest value of C would be possible when A and B are increased so much that all three become equal if possible. Is it not? Is it not? That's what we did. Yes, exactly, Mohnish. Good. So in terms of shortcut, if you wish, so we discussed that longest side should be smaller than P by 2 and should be greater than or equal to P by 3. Excellent. That can be mentioned like this. If C is the longest side, then C should be less than P by 2 for sure, and it should be greater than or equal to P by 3. If parameter is multiple of 3, in that case we can do it P by 3, or otherwise it would be more than that. We are considering the integral values here. Excellent. Is it okay? Yes, that's true. I hope it is clear to everyone now. Okay, coming to this new question now, please see it carefully and then answer. There are 10 sticks of different integral lengths, such that no 3 sticks can form a triangle. Okay, I repeat, there are 10 sticks of different integral lengths such that no 3 sticks can form a triangle. Now, question is, find the minimum possible length of the longest stick. Please answer this question fast. Drug club consultancies, please clarify the parameter of odd number. We did that earlier, isn't it? In the first question we discussed about this, we took the parameter to be 10, right? So 10 is not multiple of 3. Regarding odd number also, that doesn't matter much because we are looking for the integral values if parameter is, let's say, 13. So the longest side cannot be more than 6. Isn't it? Okay, I'm getting answer here. Sidhanshu Gandhi ji कह रहे हैं 89. Good. Others, please try to do it faster. There are 10 sticks of different integral lengths such that no 3 sticks can form a triangle. Find the minimum possible length of the longest stick. I hope question is clear to everyone. Try to reread and understand and then proceed. I'm giving you 1 more minute. Abhay, no 3 sticks can form a triangle means if you use any of the 3 sticks, it cannot create a triangle. That's it. It cannot create a triangle. Prashant, Ridhima, Sangesh, Lakshay, Mehak, Vaishnavi. Many of you are saying 3 or 4. Are Baba, all sticks are of different integer lengths and there are 10 sticks. If you take the counting numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then again answer cannot be less than 10 at least. So 3 or 4, those who are writing, it is not possible certainly. Isn't it? Yes, Upasana, please think. Try to think what is being asked. This condition which Abhay has mentioned, that no 3 sticks can form a triangle. That's the important one. Is no 3 sticks can form a triangle. What does it mean? Try to understand that. I can see some good answers here. Many of you are saying 89, Prakhar, Chandra, Siddhanshu ne pehle bola hi tha. Polo, you are saying 91. Please recheck. Sayak says 19. Khushi 512. Acha, Khushi bahut sari hain. Khushi Patil and Khushi Kumari. Khushi Kumari says 89. Ashish Kumar says cannot be determined. It can be, sir. It can be determined. Okay, let's check it now. See, again I'm asking same thing. No 3 sticks can form a triangle. What does it mean? Iska kya matlab hai? Of course, it means that those 3 sides do not form a triangle. They cannot make a triangle. And what was the condition that triangle can be made? That if longest side is smaller than sum of others, then triangle can be made. But if it is not the case, then triangle cannot be created. Then triangle cannot be formed. Fine. So no 3 sticks can form a triangle. That means if whatever 3 stick lengths if I take, the longest side is not smaller than sum of others. Fine. That is the requirement that we need to follow. Only then this can happen. ठीक है ना? And further, out of the 10 sticks, 1 stick can be of length 4. 1 stick may be. We are asking about the longest stick, Ridhima. 1 stick may be of length 4, that's fine, but we are asking about the longest stick. We are asking about the minimum possible length of the longest stick. ठीक है ना? Longest stick की minimum length क्या होगी? That's what we are asking. And all sticks are having different lengths. All 10 sticks are of different length. So of course we should start with the smallest stick length. So what should be the smallest length of the smallest stick? 1, isn't it? 1. So 1 should be the length of the smallest stick, is it not? What about the second stick's length? What should be the length of the second stick? It cannot be 1. We need to keep it minimum also. It cannot be 1 because all sticks have different length. So second stick may have length 2. Yes or no? Yes. Now tell me about the minimum possible length of the third stick. And remember this condition, the triangle should not be formed. Triangle should not be formed. I cannot take it 1 or 2 because the sticks are to be of different length. Can 3 work? 3 se ho jayega kya? What about the third stick length? 1, 2 I have already taken. Will 3 work or not? If I take the third side length to be 3, can these 3 make a triangle? Of course not, because 3 is the longest one and it is not smaller than sum of others. It is equal to sum of the others, right? So 1, 2, 3 will work. This will not form a triangle. Fine? It will work. It will not form a triangle. That's what we want, Khushi, Prashant, that we should not get a triangle. So if I take it to be 3, it will not form a triangle. Fine. Now next, moving further, what about the next 4 sticks minimum length possible so that triangle is not formed? Triangle should not be formed. Chandan, in case of 3 also triangle will not be formed, na? See, if you take 3 as a side length, this is 3, and the other stick whose length is 2, another stick whose length is 1. We can join the vertices, but the triangle, if you call it, it will be having 0 area. So triangle means which is having non-zero area. So 3 to 1 will also work because they will not form a triangle of non-zero area. So 3 will work. What about the 4th length now? Will 4 work or not? Now you're writing 5. Will 4 work or not? No, because 4 is smaller than 3 plus 2. Right? 4 is smaller than 3 plus 2. So 4 will make a triangle with 3 and 2. So 4 cannot work. Yes, 5 will work because now 5 is equal to 3 plus 2. I hope by now you are getting the pattern. What should be the next stick length so that triangle is not formed? What should be the next stick length? What should be the next stick length? 4 cannot work, Anvita, that we have seen. What about the next stick length? So that triangle is not formed. Please keep that in mind. No 3 sticks can form a triangle. That is a condition. Smallest also I want drug club consultancies. Pranjal says 8. Archie also says 8. 8, 8, 8. Yes, 8 is correct. Because if I take anything less than 8 here, if I take 6, then 6 is smaller than 5 plus 2, triangle will be formed. 7 is again smaller than 5 plus 3, triangle will be formed. If I take 8, 8 is not smaller than 5 plus 3. So 8 is the smallest possible length of the next stick. And I hope you are getting the pattern now. Can you see what is the pattern here? Khushi, triangle के लिए condition क्या थी? Remember that longest side should be smaller than some of other sides. Some of other 2 sides, of course. We are talking of triangle. So I do not want that condition to be followed. So the minimum possible length of the longest side should be equal to the sum of other 2 sides. That's what we are doing here. That's what we are doing here. Can you find the pattern anyhow now? What is the pattern? What about the next side length? 13. Yes, many of you are already writing that. 13. Do you recognize this pattern? What is happening? Do you recognize this pattern? Yes, what pattern it is? Yes, excellent, Ashish. It is called Fibonacci. Pattern of Fibonacci. Sometimes people call Fibonacci also. It's okay, whatever it is. Fibonacci or Fibonacci. So that means every next term is the sum of the previous 2 terms. That's it. So next would be 13 plus 8, that is 21. Next would be 21 plus 13, that is 34. Next would be 34 plus 21, which is 55. And next would be 55 plus 34, that is 89. We were to look for the longest, minimum possible length of the longest stick, that is a 10th stick. So how many values we have written so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yes, 89 is the minimum possible length for the longest stick. That's correct. And I guess Siddhanshu was the first person to give the correct answer. Is it clear to everyone? Haripriya, that's true. 4 is not less than 3 plus 1, but 4 is less than 3 plus 2 na. 4 is less than 3 plus 2 na. So 2, 3, 4 will make a triangle. But we want that no 3 sticks can form a triangle. We want that no 3 sticks can form a triangle. So 2, 3, 4 will make a triangle. That's why we had to omit 4. Fine? Is it okay? Haripriya, did you understand what I just said? Okay, good. Yes, Shavi, thank you. Shall we? आंखें खराब हो गई है भाई. Okay. Vaishnavi, what mean by triangle numbers? Oh, triangular numbers, that is a different thing. That's regarding numbers. Vaishnavi is asking about what are triangular numbers. So the numbers which can be arranged in form of a triangle. So for example, let me denote the numbers by circles, right? So this is one circle, this is a triangle we can say. Okay, this is 1, it represents 1, it is a triangular number. Next, it can be written something like this, 1 and then 2 more circles below this. So this also resembles a triangle, is it not? So this is 3, basically 3 circles. So this is a triangular number. And then next would be 1, then 2 circles beneath it, and there would be, in the next layer, there would be 3 circles. So total, how many circles are there? There are 1 plus 2 plus 3, that is 6 circles. So this 1 is a triangular number, this 3 is a triangular number, then 6 is a triangular number. Can you tell me what will be the next triangular number? Yes, it will be 1 plus 2 plus 3 plus 4, that is 10. So 10 is the next triangular number, and so on. Is it okay, Vaishnavi? So 10 is the next, the fourth triangular number, you can say. Is it fine? Okay, Aditya is asking maximum possible length of longest stick kya hoga? Infinite. You can go on and on, there is no limit. In place of 89, if you can extend it to anything, a triangle cannot be formed. ठीक है ना? Thank you, Archie, for helping Haripriya out. Aditya, is this point clear? You can keep on increasing this value. So there's no limit to that. Vaishnavi, is your question answered? Yes, Ridhima, 1 is also considered a triangular number, considering point also as a triangle. Considering a point also as a triangle, so 1 is also considered a triangular number. Joining the centers, here you are going to get a triangle, so 3 is also a triangular number. Joining the centers, again you are going to get a triangle, it is again a triangular number, 6, and so on. Considering point also as a triangle, so this 1 is also considered as a triangular number. Okay. Akanksha, can you repeat the question with another method? There is no another method, Akanksha. We are just using the triangle inequality here, and our requirement was that the triangle should not be formed. So we need to choose the length of the sticks in such a way that no combination of 3 sticks can make a triangle. I repeat, no combination of 3 sticks or 3 lengths can make a triangle. That is our requirement. And for that purpose, we are just making use of that simplest or the shortest version of triangle inequality, that longest side now should not be smaller than sum of others. In this question, for this question, so that triangle is not formed, we need to keep this thing in mind. So longest side should not be smaller than this. So then what can be this value? It should be equal to the other case, because I want to keep the longest length minimum also. So that's what we are doing here. So 1, 2, 3, and after that we proceeded that next side length should be minimum 3 plus 2. Because it is, if it is less than that, then that 4, as many of you were saying, then 4 would become smaller than this, and that will create a triangle which we did not want. ठीक है? Yes. Gaurav, preparation depends upon you only. There could be students who joined the earlier batches, but they are not working sincerely. And there could be students who might be joining the last batches, but still are able to perform in a nice way. So it only depends upon you, that how much committed you are. If you are committed, you can take the benefit. If you are not committed, then you may not derive any benefit. Okay, to be honest. So it's you be assured that you are going to put your 100% efforts, then I can certainly assure you, you are going to get benefit. Okay, na? So it's up to you. Can we simply use the Fibonacci sequence for this type of questions? Upasana, try to understand the concept, and then you can identify what is happening. Then we proceeded further. For every case, I didn't ask you, batao next kya hoga, because we understood what is happening and why it is happening. That's why after 2-3 terms, we use the pattern and proceeded faster. ठीक है ना? So no need to mug up the things. And of course, if you get a similar question somewhere, then you already know the answer. You already know the procedure. That is a benefit of practice. So when you practice a lot of questions, then you get many ideas, right? You develop many ideas, and whenever you see the similar question next time, then you are able to solve it faster. That's what is the effect of the practice. Okay? That's why it is being said repeatedly, please practice more and more practice. Okay. Prashant, why did we consider last 2 terms only for the 3rd term? You think on your own, then come up with your series. Prashant, I'm leaving it for you. Please think on your own, then answer. Okay, let's proceed further now to the next concept. So far we have discussed what are triangles and what side lengths can make a triangle, and we have discussed various questions, various varieties of things using the same concept repeatedly. Check. So let's proceed further now. How many minimum sets of LR should be performed daily? As much as you can do, Riddhima. It's better if you can solve at least 1 or 2 sets daily, but if you can spare more time, it's nice. Okay, so I'm moving further now. Okay, so yes, next property regarding triangles, and some of you were talking about trigonometry. So here is the use of trigonometry here. So there are two trigonometric rules, sine rule and cosine rule of triangle, and these are very helpful sometimes. These are very helpful sometimes. So what are sine rule and cosine rule? So though basically these rules, these trigonometric rules relate the side lengths and the angles of a triangle. I repeat, they just relate the side length and the angles of a triangle. So what is the relation? How do they relate with each other? So if this is a triangle, let's call it A, B, C. So angle at vertex A is angle A, vertex B, angle B, vertex C, angle C. So the side length opposite to vertex A is having length denoted by a small letter A. Opposite to B, it is small letter B, and opposite to C, this is small letter C. So this side length is C, this side length is A, this side length is B. Now sine rule says that these side lengths, as we were saying earlier, that angle opposite to the longer side is larger than the angle opposite to the smaller side in a triangle, in same triangle. So what exactly is the ratio? If I say that angles are in the ratio 1, 2, 3, what about the side lengths opposite to them? Will they also be in the ratio 1, 2, 3? No. Okay, I repeat, what did I say? मैंने बोला कि if it is given that, let me ask you a question like this. The three angles of a triangle are in the ratio 1:2:3. Okay. Now question is, what's the ratio of their opposite side lengths? But the ratio of their opposite side lengths. Okay, I'm waiting for your answers. It's given that the three angles of a triangle are in the ratio 1:2:3. Question is, what is the ratio of the opposite side lengths? Of course, 1 is the smallest angle here. 1, 2, 3 is the ratio of the angles, is the ratio of the three angles. So the smallest angle is with the ratio 1, and the 3 is the largest one. So what about the side lengths? Of course, the side length opposite to the smallest angle would be the smallest, and side length opposite to the largest angle would be the largest. But is the ratio going to be 1:2:3 only? Oh, we are getting different answers. Aditya says saying cannot be determined. No, Aditya, it can be determined. Abhay says 3:2:1. No. Madhav 3:2:1. No. 3, 4, 5. No. Okay, see, all different answers and wrong answers, by the way. Now see, so it is not directly 1, 2, 3. See, this thing is very clear. The the side length opposite to smallest angle would be smallest, na? Why you are reversing it? It cannot be reversed. Certainly, the side length opposite to the smallest angle would be smallest. The larger angle would be larger, and the largest angle ke opposite side length would be the largest. So 3:2:1 is certainly wrong. 3:2:1 is certainly wrong. Yes, 1, 2, 3 could have been the most obvious answer, but it is wrong. It is not correct. 1, 2, 3 could be the most obvious answer, but it is wrong. It is not correct. And yes, I can see what angle here? Tejeshwar. That's correct. 1:√3:2. That's correct answer. Yes, Monish, that is true. It would be 30, 60, 90 triangle. Excellent. Excellent. See, first point here would be to determine what are the three angles. So can you find out the three angles of a triangle which are in the ratio 1, 2, 3? Can you find these angles? These angles come out to be 30, 60, 90. कैसे पता लगा? Because the sum of the three angles is 180 degree. So if one angle, the first angle is x, then the second one is 2x, then the third one is 3x, and their sum is equal to 180 degree. Yes or no? So this total comes out to be 6x. So So 6x equals 180 degree. It means x equals 30. So the three angles here being talked about are nothing but 30, 60 and 90. Right? That becomes a right angle triangle. So now side length opposed to them, they are not in the ratio of 1:2:3, which appears it to be. It's not. So they are related by this sine rule. And what does this sine rule says? So sine rule says that A upon sine of angle A would remain constant. A side length upon sine of the opposite angle, sine of the opposite angle, this ratio is going to remain constant. So A upon sine A is equal to B upon sine B is equal to C upon sine C. So that is a trigonometric relation. So the angles, now this angle is 30, 60, 90 if you are talking about this question. So the side lengths are not in the ratio of 30, 60, 90. Side lengths are basically in the ratio of sine of those angles, sine 30, sine 60, sine 90. Fine. And accordingly we can find our answer. Answer has been already mentioned by a few students as well. So this ratio is going to be constant and it is also equal to basically 2r, where this capital R denotes the circumradius, radius of the circumcircle, a circle which passes through the three vertices. Anyway, this is the extra information. So the sine rule relates the side length as along with the angles of the triangle. Is this point clear to everyone? So you can easily answer this question if you know the values of sine of these angles. So sine 30 कितना होता है, sine 60 कितना होता है, sine 90 कितना होता है, and so on. ठीक है? So I hope you know that sine 30 कितना होता है. What is the value of sine 30? So sine 30 is 1/2. Sine 60 is root 3/2 and sine 90 is 1. Fine. So using these values, you can answer this question very easily. Answer has already been mentioned. So let me rewrite. So answer comes out to be 1:√3:2. So that is the answer to this question. Okay. So that is one of the trigonometric rules, which is sine rule. So if you know, if you are aware about these trigonometric values, then you can make use of this. Then this is very easy, good thing. Okay. Yes, capital R was circumradius. This capital R is circumradius. Okay, now the next trigonometric rule is a cosine rule. So this cosine rule is also a relation between the side lengths and the angles. This cosine rule is also a relation between the side lengths and the angles, and this is also sometimes very useful while solving questions, although a CAT doesn't exactly use it. Ashish, I mentioned this is circumradius. We are not going to discuss about this in detail right now, but anyway, this capital R is circumradius. Circumradius का मतलब ये होता है the radius of a circle which passes through all the three vertices of a triangle. यानी कि if I draw a triangle, if I draw a circle which passes through all the vertices, which passes through all of its vertices, then radius of this circle is known as circumradius. So we can find out the length of its radius by using this relation. ठीक है? Is it fine? Okay, Aditya saying something. जब three altitudes का measure दिया है, then ratio of three sides of triangle. Yes, that's true. That's true, Aditya. Yes, that's true. Okay, coming back here. So what is cosine rule? Let me write. So cosine rule, as I said, it is also a relation between the three sides and the angles. So it basically tells that if we know the three sides of a triangle, let's say ABC, then we can determine the cosine of the angle, So let's say I know the three sides and I need to find the cosine of angle A. So according to this cosine rule, so cos of angle A can be found out using this relation. It is B square plus C square minus A square upon 2BC. Now see it again. If I want to find the value of cosine of angle A, so I need to find the value of cosine of angle A. So the adjacent sides, they are B and C. So right, so sum of these two squares, so B square plus C square minus the square of the opposite side, that is minus A square, upon 2 into the product of the adjacent sides. That's how you can remember it. Fine. So B square plus C square minus A square upon 2 into B into C. So these are the two trigonometric relations that you study in your 11th and 12th classes in mathematics. So those who have studied mathematics in 11th and 12th as well, you are familiar with them already. And if you have not done, so then you can do that, then you can use them if you are familiar, if you are comfortable with using trigonometry. But otherwise we can avoid it also. We can avoid it also by some other methods that we are going to discuss. Okay, so I hope till this point it is fine. Okay, now let's apply it to become more familiar. So we have seen both of the relations, so sine rule and cosine rule. So by using cosine rule, if we know the three side lengths, we can find out cos of the angle, or vice versa also. Basically, there are four things being used, three side lengths and an angle. So out of these four, if we know any three things, we can find out the other thing. For example, if I know the side length B, side length C and the angle A, then I can find out the remaining length also, isn't it? So that's how both of these trigonometric rules can be used to find out the side length or the angle of a triangle. Okay, let's answer some question now. And I also mentioned you that we can avoid using trigonometry as well. That's also we are going to discuss. But first answer this question. Question is, find the value of x in this given figure. This is a triangle, you can see that two angles are given, 60 degree and 45 degree, and this one side length is given 9 centimeter. You have to find the length, the value of x in this figure. Please answer this question. Urvashi, this question we are going to discuss, don't worry. Urvashi, please copy this question and ask me later if it is missed somehow. We are going to discuss it in this class for sure. Akanksha, don't worry. If you had not studied mathematics in your 11th and 12th classes, so don't worry. You can avoid trigonometry completely, don't worry. But if you think that you can, then that was the only thing which you are supposed to do. Till 10th class, you have studied about trigonometry, sine kya hota hai, cosine kya hota hai, and those values also, sine 30, sine 45, sine 60, similarly for cos also, tangent also. So those things are sufficient. We don't need anything more than that. But even that can be avoided. So don't worry, we are going to discuss that part also. Okay? Okay, I have got one answer from Tejeshwar. 9 times root of 3 by 2. Good. Waiting for the answers. Okay. Chevy has given the same answer. Yes, Sayak, that's true. We have rationalized the denominator. So it is same answer as given by the earlier students. McGomick again with same answer. Okay, let's see it now. See, we can make use of sine rule which we just discussed, isn't it? We can make use of sine rule we just discussed here. Madhav, you missed one root 2 here. Okay, let's see it now. So this is a triangle in which we are given one side length and the two angles, and we require this one side length. Now the angles given are opposite to these side lengths only. This side length opposite to 45 is 9 centimeter, and side length opposite to 60 would be what? That is being asked. So if I use sine rule, so it simply says that x upon sine 60, let me write, it says x upon sine 60 should be equal to 9 upon sine 45, yes or no? It should be equal to 9 upon sine 45 degree. Is it fine? ठीक है ना? So you can solve this question using this sine rule, provided you know the values of sine 45 and sine 60, and that you have done in your 10th class. That's what I answered earlier also to someone. I think कोई तो था किसको I answered that. So I think Akanksha, yes, I talked about Akanksha. So if you remember the values of all these trigonometric ratios, sine 45, sine 60, then it is not very difficult thing, right? By just using that simple rule of sine rule, So we can answer this question. So I hope you know that sin 45 kitna hota hai? It is 1 upon root 2. And what about sin 60? Can you tell me in the comments what is the value of sin 60? Madhav, sin 45 is not 1 by 2, it is 1 by root 2. Yes. 1 by root 2, Madhav. And what about sin 60? Sin 60 is root 3 by 2. I mentioned in the previous slide as well. Sin 60 is root 3 by 2. So just put these values and you will get your answer. So basically x comes out to be 9 upon sin 45, which is 1 upon root 2, into sin 60, which is root 3 by 2. ठीक है ना? So simplifying, this root 2 will come at the top here. So 9 times root 2 into root 3 upon 2. So if you want to keep your denominator a rational number, so it is 9 root 6 by 2. Or if you wish to, if you are ready to make it irrational number, then you can cancel out a root 2 here. So it will be 9 times root 3 upon root 2. This would be 9 times root 3 upon root 2. That's also fine. The same thing. Is it okay? So that's using sine rule, right? It was direct application of sine rule. Just apply the sine rule, we got our answer. That's it. And only requirement was that we must know the value of sine 45, sine 60 and so on. So these basic trigonometric values we were supposed to know. Is it okay? Right. So this is the answer here. Now coming to that part, how can we avoid using trigonometry? Can we avoid and should we avoid? Yes, we can avoid. And should we avoid or not? It's up to you. If you are comfortable with trigonometry, then no need to avoid. If you are not comfortable with trigonometry, then you should avoid. Certainly, you should look for the way how, without leaving the question, how can I avoid trigonometry? What is the alternate way? So the alternate way are two spatial triangles. I repeat, the alternate way is are two spatial right angle triangles. And what are they? Let's see now. There are two spatial right angle triangles. One is 30, 60, 90 triangle. You can call it 30, 60, 90 rule. And the other case is 45, 45, 90 rule. What is the importance of these? See, in your 10th class, whatever trigonometric ratios you have remembered, they were about these angles only, 30 degree or 45 degree or 60 degree or 90 degree, nothing else. Right? You know the value of sine 30, you know the value of sine 45, you know the value of sine 60, you know the value of sine 90. But do you know the value of sine 179 degree? No. We can find some of the values of sine or cosine of some other angles which are in combination of these, and that you have done in your 11th and 12th classes. But you cannot find the value of sine of 179 degree, 167 degree and so on. Right? We cannot find those values. We cannot find the value of any of that angles. Right? So for some specific angles only we can find their trigonometric values. So to avoid all that part, so these are two special triangles. One is 30, 60, 90 triangle and other is 45, 45, 90 triangle. Now what is special about them? Please be very careful and remember them. They are very, very useful and specifically to avoid using trigonometry. And we are going to apply it also there. So 30, 60, 90 triangle means that this one angle is 30 degree, the smallest angle, and this is 90 and of course this is 60. And this is, by the way, same case which we just discussed in the previous question. These three angles are in the ratio 1:2:3. Okay. Now, what about the side length? So, what thing we are going to remember now is this. What is the ratio of the side lengths in this case? So, the smallest side length would be opposite to the smallest angle. I repeat, in this case, the smallest side length would be opposite to the smallest angle. Is it not? And the smallest angle is 30 degree. So, if the smallest side length, that means which is opposite to 30 degree, if it is x, then the longest side length which is opposite to 90 degree is going to be simply double of this, that is 2x. And let's just make use of that trigonometric ratio only. You remember what is sine 30? Sine 30 is equal to 1/2. Is it not? Yes. And sine value is the ratio of perpendicular upon hypotenuse. So if this is x, then this should be 2x. So as to keep the ratio 1/2, which is sine 30, is it not? So now, in spite of remembering this, let's try to remember this only. So if 30 ke opposite it is x, then 90 ke opposite it is going to be twice of that, twice of x. Fine. Now what about this side length which is opposite to 60 degree? How to calculate this without using trigonometric ratios? How to get this? Yes, you can make use of Pythagoras theorem. Is it not? You can make use of Pythagoras theorem, which says square of the hypotenuse is equal to sum of squares of the other two side lengths. Fine. So this length comes out to be root 3x. Is it okay? Is it okay? Okay. Okay. So this is an important relation here. This 30, 60, 90 triangle. So if the side length opposite to 30 degrees x, then 60 ke opposite it is going to be root 3 times that x, and 90 ke opposite it is going to be twice of that x. Okay. And the other case, the 45, 45, 90, it is quite simpler now because these two angles are same and these two are smaller angles as well. So if opposite to this 45 degree, if we are having x, then opposite to this other 45 also this is x. Can you tell me what will be the length of this hypotenuse now? Again, use Pythagoras theorem. Don't use the trigonometric ratios. What will be the length of this hypotenuse here? We can use the Pythagoras theorem. So it is going to be x square plus x square ka root. That is root 2 times x. So the ratio here is 1 is to 1 is to root 2. If this is 1, then this is also 1 and this is going to be root 2. If this is 2, then this is also 2 and this is going to be twice of root 2. Is it not? So these are the two special cases which are very helpful to avoid the use of trigonometry. Riddhima, I mentioned that using sine 30 we just recalled here. Sine 30 was perpendicular upon hypotenuse. So if perpendicular upon hypotenuse is 1 by 2, so this x upon 2x will be 1 by 2 because it is sine 30. ठीक है ना? There are other ways also, but right now we had just discussed about these values of angles, so I just use that only. But our purpose is to avoid this now. So if you remember these two special cases and use them, so most of the times you can very easily avoid trigonometry. I repeat, if you remember these two special triangles and if you use the ratios of the side length, so then most of the times you are able to easily avoid using trigonometry. ठीक है? Is it okay? हाँ, yes, Madhav, that's correct. So 90 के opposite वाला जो side length है, that is twice of the side length which is opposite to 30. So here the ratio is 1 is to root 3 is to 2. Let me write the answer here. So 30, 60, 90 triangle में what is the ratio? 1 is to root 3 is to 2. That is the ratio of the sides. ठीक है? The side length opposite to 30, opposite to 60 and opposite to 90. Same way in case of 45, 45, 90, the ratio of the side lengths is 1 is to root 2. That's it. So that is the conclusion basically. That is the conclusion. Okay, now let's use the same thing in the previous question. In this previous question, I don't want to use trigonometry. Can we use this? Can we make use of that special triangles? Let's tell me what we can do here. Here it is 60 degree, here it is 45. There is no 90 degree angle here. How can we make use of those two special triangles? Remember, we discussed about two special triangles, 30, 60, 90 and 45, 45, 90. But यहाँ पे तो 30, 60, 90 or 45, 45, 90 नहीं है. So what to do? Now we need to do one construction. And what is the construction? So from this vertex, let's drop a perpendicular. Let's drop a perpendicular. So I have created this angle 90. Now this is 90, this is 45, so this is also 45. So that becomes a 45, 45, 90 triangle. And same with the other triangle. This is 90, this is also 90. So 90, 60 and 30. So that becomes a 30, 60, 90 triangle. Is it fine? That's it. That becomes a 30, 60, 90 triangle. Now in this 30, 60, 90 triangle, you can easily use the ratio of the side lengths. It depends upon you, Lakshay. That's what I said. Those who are familiar with trigonometric ratios, they can make use of that. There's no harm in that. But if you are not comfortable and if you want to avoid, then make use of this. It's really simpler. I find it to be simpler, but certainly I'm not against that also. Okay, now let's see what are the values. We are almost done now. So in this 30, 60, 90 triangle, 90 ke opposite it is 9. So what about opposite to 30? It is going to be half of that. That is 9 by 2. That was our ratio. 30 के opposite जो भी length है 90 के opposite it is going to be twice of that. ठीक है ना? And 60 के opposite root 3 times of this. So this total length is 9 by 2 times root 3. Is it fine? That's it. No need to remember anything. I'm just making use of the ratios. If you remember that. Check. Now let's next part. So in this case, this is a 45, 45, 90 triangle. Yes, that's all. Sine, cos, tangent only, of course. These are the things which you are going to use. But benefit of using these two special right triangles is that you don't need to remember any of the ratios. Otherwise, sine, cos, tangent, सबका 30 degree, सबका 60 degree, सबका 45 degree, सबका 90 degree. Isn't it, Lakshay? That is a troublesome task. But if you have already done that, that may feel easier. It's okay. So, but still I would say again, it is easier than remembering all those values. Even if you remember, still avoid that. It is better case. So now this is 45, 45, 90 triangle. So this is 9 by 2 times root 3. So this would also be 9 by 2 times root 3. And this is going to be root 2 times. Remember the ratio? It was 1, 1 root 2. So whatever is this side length, so the hypotenuse is going to be root 2 times of this. So we directly got our answer. It is going to be root 2 times of this. That is 9 by 2 into root 3 into root 2, which means 9 times root 3 by 2. That's it. So this is our answer. Okay. So that's how you can easily avoid using trigonometric ratios if you remember these two special triangles. And these two special triangles are going to be used repeatedly in many places because you do not know the value of any other trigonometric ratios other than these specific angles, as I mentioned. That's why there is nothing being proud that I know trigonometry. You can know trigonometry, but you know trigonometry to a very less extent. And that much is only required. And that can be done very faster by making use of those two special cases of triangles, right triangles. ठीक है? Okay, let's proceed further now quickly. So we are going to discuss few more properties. Is it clear so far? Any doubt? Sir, where did into 2 root came? अरे 2 root वहाँ पे आया था ना? Here it is. In 45, 45, 90 triangle, the ratio of side is 1 is to 1 is to root 2. So 1, 1 root 2, x, x root 2x. So in the previous question which we just did, so this is 45, 45, 90 triangle. So this hypotenuse is going to be root 2 times of this value. That's what I have done. So 9 by 2 times root 3, uska root 2. So that's our final answer. Is it okay, Janardhan? Fine. These are only two trigonometric properties we are going to use, Prayush, sorry. Okay, let me ask you one more question that should give you more clarity. So there is an equilateral triangle. There is an equilateral triangle with side length 2. Okay? Another equilateral triangle of same size, another one, and one more. Okay? So now these are 4 equilateral triangles, each of side length 2. So question is you need to find out the length of this longest diagonal of this quadrilateral. ये जो पूरा बड़ा quadrilateral बन गया है, इसमें the longest diagonal, you need to calculate this length. Please tell the answer fast. Yes, Shruti, that's what I am saying. Using these two ratios, using these two special right triangles is better. Even if you know the trigonometric ratios, still it is better. Okay, in this case, now all are equilateral triangles, you need to find the length of this dotted line, which is basically the longest diagonal. How to solve this one? Now let me tell you. So in this triangle, if we see, can you tell me what is this horizontal length? This is 2, this is also 2, and this is also 2. So this is 4 and this is 2 basically, right? 4 and 2. What about the angle here? What about this total angle here? It is 60 degree plus 60 degree. Total makes it 120 degree. Is it not? So basically the length which we need to find out is the third length of a triangle whose two side lengths are known to us, 4 and 2, and also the intermediate angle is also known to us. It is 120 degree. And this dotted side length, let's call it x. That's what we need to find out. That's the question here basically. है ना? So how to answer this question? What method you can use here? माधव जी बोल रहे हैं 2√5. Is it so? I don't think. That's not correct, Madhav. Please recheck. By the way, this is a question from previous CAT only. I think at least 10-15 years ago, maybe more than that. Yes, hello Vivek. Please answer this question fast. After this, we are going to discuss some more properties and we are going to reach up to similarity part. Arey Baba, this was equilateral triangle. All these four are given equilateral triangles. These are 4 equilateral triangles. All these 4 are equilateral triangles, right? That is given. Okay, Srishti? Yes, what method is there to answer this question? What we can do? Any hint, anything comes to your mind? Sine rule, okay? But you know only one of the angles. Other angles, do you know the other angles? Jiba, Ziba. We know the side lengths to be 2 and 4, but we don't know the angles opposed to them. Yes, cosine rule can be used here, right? Cosine rule can be used. If we are using trigonometry, then cosine rule may be used. That's fine. And perpendicular dalo, Agraj says. That looks interesting. But before that, if I'm using trigonometric rules, then cosine rule would be the one which will help us. In this case, the 3 side lengths are 2, 4 and x, and the angle between these 2 intermediate sides is given. So we can make use of cosine rule here, right? And for that purpose, you need to know the value of cos of 120. Can you tell me what is the value of cos of 120? Let me write here only. ये लिख लेते हैं. Cos of 120. What is the value of cos 120? Can anyone tell? What is the value of cos 120? Yes, Megomic, that's the right answer, by the way. Good, Shavi, that's correct. What is the value of cos 120? Those who are comfortable with trigonometry, how to find the value of cos 120? It is 90 plus 30, that comes out to be negative sine 30. It is cos of 90 plus 30, and cos changes, is a complement of cos, is sine only. So it is sine 30, and because this is in second quadrant now, and where cos is negative, it is negative of sine 30, and sine 30 we know it is 1 by 2, so it is minus 1 by 2. So cos 120 is basically minus 1 by 2, right? And using cosine rule here, the cos of 120 is going to be 2 square plus 4 square minus x square upon 2 into 2 into 4. We just wrote that in the previous slide, right? That was the cosine rule. So now simplifying this, you can find the value of x. ठीक है ना? So 2 से 2 cancel कर देते हैं. 4 into 2, 8. This is minus 8 equals 2 square, that is 4, plus 4 square, which is 16, minus x square. So this x square comes out to be 20 plus 8, that is 28, and x equals to square root of 28, which can be further simplified as 2 root 7. So this is the right answer. Using trigonometric rule, this cosine rule, we could have solved it easily. Okay, now how to avoid a trigonometry? That was the whole idea. Let's see that. So I got one good suggestion by someone, I forgot the name, sorry, regarding drop a perpendicular. See, if I drop a perpendicular from here on this baseline being extended, so this is going to be 90 degree because I have dropped a perpendicular. And can you tell me what would be this length? Dhyan do, I have dropped a perpendicular here. This is 90 degree now. What about this length? What will be this length? Please tell me fast. This is going to be half of the equilateral triangle sides. Calm and relaxing cosine formula is that only. We wrote the formula in the previous slide and we are using it here directly. This is cosine rule. Yes, Khushi Patil, Ziva, that's perfectly fine. Though this is going to be 1 because it is simply half of the side length of this equilateral triangle. This is 1. And what about this perpendicular height? This is height of the equilateral triangle. What is the height of this equilateral triangle? Please tell me. Yes, it is root 3. That's it. That's it. So finally, the length x which we need to find out is simply the hypotenuse of this right triangle. This is x. This is root 3. And what about this side length? This is 2 plus 2, 4 and plus 1, 5. Just use Pythagoras theorem and get your answer. We are done. So it is 25 plus 3, that is 28. You know Pythagoras theorem? So x square equals to 5 square plus square of root 3. That is 25 plus 3, that is 28. So x comes out to be root of 28 or same 2 root 7. Now, which method to adopt? It's your choice. Okay? So, one common thing you can observe is that while we are trying to avoid using trigonometry, in that case, we always need to create a right triangle and we need to do some construction. But while using trigonometry, no construction is required. But calculations may be a bit lengthier. You may need to remember some of the formulae, but no construction is required. So if you are able to do some constructions to make the things simpler, it is certainly for you. Okay, so it's your choice now. So I hope it is clear. Clear to everyone? Shall we proceed further now? Is it okay? Okay, I feel right. Thank you, Ziba and Shruti. Okay, let's proceed further now. So we are moving to the next thing, the types of triangles. Good. Types of triangles. So there are basically different types of triangles. Initially, when I asked you, yes, Shavi, it is till 9 only. We have around, I think, less than 30 minutes remaining now. Manav, that was half of equilateral triangle, na? Okay, so types of triangles. So there are different types of triangles you were mentioning earlier. So let's see that. So basically, we can divide the triangles in 3 types on the basis of the angles and also on the basis of sides. So when talking about in the terms of angles, so there are 3 triangles which are known as acute angle triangle, where all the 3 angles are acute angles. Acute angles means which is less than 90 degree. Acute angle means which is less than 90 degree. So when all the 3 are acute angles, that triangle is known as acute angle triangle. The other case is right angle triangle. So when one of the angle is right angle, so other 2 are going to be acute. So this is a right angled triangle. And the third case is obtuse angle triangle. This is obtuse angle triangle. Fine. So according to the angles, there are three different types of triangles: acute angle triangle, right angle triangle, obtuse angle triangle. Obtuse angle is the angle which is more than 90 degree. Obtuse angle means which is more than 90 degree. Right angle means which is equal to 90 degree. All these things you already know. ठीक है ना? And out of these, the special case is this right angle triangle only. The special case is right angle triangle only. Now, how to find out according to side lengths whether the triangle is going to be acute angle or right angle or obtuse angle? That's the important part. And the question have been asked in CAT repeatedly on the basis of that. I will repeat. If we know the three side lengths of a triangle, then how are we going to get to know whether the triangle is going to be acute angle triangle or right angle triangle or obtuse angle triangle if the three sides are A, B and C? Okay, do you know what is the relation between the three sides of triangle in case of a right angle triangle? What is the relation between the three sides of triangle in case of a right angle triangle? Please mention that. That's known as Pythagoras theorem, isn't it? So if A, B and C, if C is the longest side, if C is the hypotenuse, so C square is going to be equal to A square plus B square. Fine. So if for a triangle, the three sides triangle can be formed, we just need to see what about the square of the longest side. If square of the longest side is equal to the sum of squares of other two sides, that confirms it is a right angle triangle. ठीक है ना? Yes. So what happens in case of obtuse angle triangle? In case of obtuse angle triangle, if this C is the longest side here, these are let's say A and B. So in this case, this C square becomes more than A square plus B square. So just by seeing the three side lengths, if they satisfy this condition that the square of the longest side becomes more than sum of squares of other two sides, that confirms that triangle is obtuse angle triangle. Is it fine? These are important relations. They have been used in CAT repeatedly. That's why we are talking about this. And so please make note of this, that you don't forget, and how to apply we should also understand. So if the longest square of the longest side is more than sum of squares of other two sides, it represents an obtuse angle triangle. If it is equal to square of the longest side is equal to sum of squares of other two sides, it represents a right angle triangle. And the last case, if the longest side, let's say this C be the longest side maybe, again, so C is the longest side. If C square is less than A square plus B square, so it confirms that triangle is acute angle triangle. ठीक है, ध्यान रहेगी ये बात ये. So what was the common thing among all of them? So common thing was that C is the longest side. I'm writing it here. If C is the longest side and it satisfies any of the three relations, because one of the three relations is going to be satisfied, either the square of this longest side is going to be smaller than sum of squares of other two, or it is going to be equal to sum of squares of other two, or it is going to be more than sum of squares of other two. कुछ ना कुछ तो होगा ही ना. So just by knowing the three side lengths, we can find out that what type of triangle it is: acute angle triangle or right angle triangle or obtuse angle triangle. Till this point, is it okay? That's fine. Okay, let's move further now. So similarly, there are three types of triangles. There are three classifications on the basis of side lengths as well. On the basis of side lengths also, we can divide the triangle in three types. One is known as scalene triangle. Scalene triangle means all the three side lengths are different. A, B, C, let's say. So where A is less than B, less than C. So this is known as scalene triangle, where all the side lengths are different. Okay? All the side lengths are different. Another special case is isosceles triangle. Isosceles triangle, where two sides are equal. This is known as isosceles triangle. So in isosceles triangle, isosceles, not T, isosceles triangle, where two sides are equal. And the third one is, yes, equilateral. where all the three sides are equal. That is known as equilateral triangle. Let's talk about all of these triangles quickly. What do you know about equilateral triangle except all the three side lengths are equal? What else? और क्या पता है इसके बारे में? In case of equilateral triangle, what else do we know? All the three sides are equal. Other than that, it is equiangular as well. All the three angles are also equal, isn't it? All the three angles are also equal. How much? What is the value of each angle? It is 60 degree. ठीक है ना? All the three angles are also equal. So if A is the side length, then what about the height? Height comes out to be √3 by 2 times A, because if I drop a perpendicular, it will meet at its midpoint. So in the previous question we used that part only. Someone was asking कि 1 कैसे आया in the last question. It is because of that only. If I drop a perpendicular, so it is going to meet the opposite side at its midpoint. It's because of symmetry, you can see very easily. Is it not? ठीक है ना? So angles सभी same होते हैं, and when you drop a perpendicular, it will meet the opposite side at its midpoint. So if this is A, this is A by 2, this is going to be √3 by 2 times A. It also becomes a 30, 60, 90 triangle. You can make use of that ratios as well. Is it not? You can make use of that ratios as well. So height comes out to be √3 by 2A, and area of equilateral triangle specifically is √3 by 4A square. Just by knowing the side length, we can find out the area of this equilateral triangle also. And this equilateral triangle is the most important case, because most of the times you are going to get questions on the basis of equilateral triangle. And these are the very basic things about height of an equilateral triangle and the area of an equilateral triangle. ठीक है? Isosceles we have already talked about. The two sides are equal. And what else? So the two angles, the two opposite angles, they are also going to be equal. So which angles are going to be equal? Those angles which are opposite to the equal sides. ठीक है ना? ऐसा नहीं कि कोई भी दो angles को equal कर दो. Only those angles are going to be equal which are opposite to the equal sides. So if we are given two equal angles, then we know that opposite sides are going to be equal. So it's vice versa. ठीक है? And scalene triangle, as we said here, all the three side lengths are different. It means all the three angles are also different. ठीक? So let's proceed further now quickly. So okay, here's a question now. The sides of an obtuse angle triangle are 6, 10x. Find the total number of possible values of x. Please answer it fast. And these are the variety of questions which I was telling you that they have appeared in CAT repeatedly. The three sides are given to us 6, 10 and x. Certainly you can find the different values of for x. Question is, find the total number of possible values of x, where x is a natural number, such that the triangle becomes an obtuse angle triangle. This is clearly mentioned here. Triangle must be obtuse angle triangle. √3 by 2 here. Height becomes √3 by 2. √3 by 2 times side length. Okay, remember the three conditions? I told you the longest square of the longest side, the square of the longest side must be more than sum of the squares of other two sides for the triangle to be obtuse angle triangle. That was the condition. So now what is the longest side here? It may be 10 or x. We just need to make the condition. So if x is the longest side, then x square should be more than 10 square plus 6 square. Or if 10 is the longest side, in that case 10 square should be more than x square plus 6 square, which means x square should be less than 10 square minus 6 square. So that is the required range here, is it not? So this x square should be more than 100 plus 36, that is 136, and it should be less than 100 minus 36, which is 64. ठीक है ना? Right? So that means x should be, now 136 is not a perfect square number. It lies between 11 square and 12 square. 12 square is 144 and 11 square is 121. So that means x must be greater than or equal to 12 because 12 square is more than that. Now this 64 is 8 square, so x must be less than 8, or basically x must be less than or equal to 7. So that is the range here. X must be 12 or more and 7 or less. But how much less or how much more? So what is from where we can get the range? From the triangle inequality. From there we know that this x must be certainly less than 10 plus 6, which is 16. X must be more than 10 minus 6. That is using simple triangle inequality. This was the condition for obtuse angle triangle, and this was the condition for basic triangle only. So from here we get to know that x must be certainly less than or equal to 15. It should be less than 16, so maximum it can go up to 15, right? So from this condition, it should be starting from 12 and up to, it can go up to 15. So 12, 13, 14, 15. These are the 4 values in this range here. And on the lower side, if I see, so x should be less than 4, right? 10 minus 6 is 4. Sorry, x must be greater than 4. So 4 से ज़्यादा होना चाहिए. So minimum it has to be 5. It should be more than 4. That means minimum it has to be 5. So x 5 से ज़्यादा but 7 तक, right? So 5, 6 or 7. So 5, 6 or 7. So these are the all 9, the 7 values possible for x here. Fine. So that's the right answer. Is it okay? So this condition we have already discussed. So we just need to introduce this one extra condition for this triangle to be obtuse angle triangle. So basically we have used 2 conditions. One was the condition for the triangle to be formed, and second was the condition to confirm that triangle becomes an obtuse angle triangle. So what was that condition? That square of longest side must be more than sum of squares of other 2. Is that fine? Yes, 7 is the right answer. Priyanshu, why less than? Which less than? More was the condition here. Square of longest side should be more than sum of squares of other 2 for obtuse angle triangle. And for acute angle triangle, it was completely opposite. And here's the next question. Please apply in the same concept in the next question also. Now this is talking about the acute angle triangle. If the sides of an acute angle triangle are 10, 14x, find the total number of possible values of x. Please solve it now. It's exactly similar question, this time for acute angle triangle. Agraj, why do we take 12? Because it is x square should be more than 136 now. Now think about that. Are Priyanka, we use the range na, x square, we found in the last question that x square should be more than, in the previous question it was x square should be more than 136 and less than 64. So how can we take 9, 10, 8, 9, 10 or 11? If you take x equal to 8, then x square will become equal to 64 now, which is not allowed. ठीक है ना? If you take x to be 9 or 10 or something 11, it is not going to satisfy. We need to simplify, we need to satisfy this condition. Okay, in this question, now the longest side square should be smaller than sum of squares of other 2. So if x is the longest side, in that case x square should be less than 14 square plus 10 square. And 14 being the longest side, so the result would be x square should be more than 14 square minus 10 square. That is the condition for the triangle to be acute angle triangle. And before that, we need to see what is the condition for the triangle to be formed. Triangle banega hi kab? When x is less than 14 plus 10 and more than 14 minus 10. So we need to look for those values of x which satisfy both the conditions. So agar isko dekhta hu, to it says x should be less than 24 and more than 4, which means x should lie between 5 and 23. X should be less than 24, so maximum it can be 23. So anything in this range, including the boundary values, will form a triangle. But for triangle to be acute, this is the required condition. Now simplify this. 14 square is 196 plus 10 square is 100, so 296. X square must be less than 296. Same way here, it is 196 minus 100, that is 96. ठीक है ना? So from here, what will be the values of integral values of x? So x should be certainly more than or equal to 10. because 96 is smaller, so x square need to be more than that. So the nearest natural number is 10. 10 square is 100. And here it comes out to be how much? 17. 17 square is 289 and 18 square is 324. But x square should be less than this. So 17 is the maximum limit. So 10 to 17 are in this range only, of course. So these are the all values from 10 to 17. Kitna ho gaya? 10 to 17. X can be anything from 10 to 17. Again, as we did earlier. So 1 से लेकर 17 तक, these are 17 values, leave out the 9 earlier ones. 17 में से 9 गए तो it is 8. 8 is the right answer. ठीक है ना? 8 is the right answer. What are those 8 values? 10, 11, 12, 13, 14, 15, 16, 17. So 1, 2, 3, 4, 4 values here, 4 values here. Total 8 values are possible. Okay. ठीक है. Let's move quickly now. So right angle triangle and Pythagoras triplets. So right angle triangle के Pythagoras triplet के बारे में बात कर चुके हैं. Pythagoras theorem के बारे में. There are few Pythagorean triplets. We must remember the initial ones at least. So the smallest primitive Pythagorean triplet is 3, 4, 5. I hope most of you know this. 3, 4, 5. This is the smallest primitive Pythagorean triplet. Let's use it. Suppose it is given that this is a right angle triangle. This is a right angle triangle. And this is 36 and this side length is 60. Not this is 60. You have to find out this length. Please answer it fast. Please answer this question fast. This is right angle triangle. So where 2 side lengths are given, you have to find out the third side length. Answer fast. This class is about to end, Kriti, in just 5-10 minutes maximum. 9 is the schedule time, by the way. So we may extend it by, I think, 4-5 minutes at least. Please answer this question fast. The 2 side lengths are given, 36 and 60. Yes, 3, 4, 5 is right there, Jones. 3, 4, 5 is the smallest primitive Pythagorean triplet. And all its multiple will also become the right angle triangles only. So in this case, what is the answer here? Yes, 48 is correct. Good. How did you do it? Using Pythagoras theorem, certainly 36 square plus this question mark square should be equal to 60 square. That's one of the ways. Isn't it? So we can simplify 60 square, we can calculate 36 square, we can simplify, subtract, and then yes, exactly. That's a good thing, Megomic. Nice. So basically, it is a multiple of that 3, 4, 5 triplet only. So the moment you know this Pythagorean triplet, you can identify, अरे बाबा ये तो इसी का ही multiple है. How did we get to know this? See, do you see any common factor in 36 and 60? Is there any common factor in 36 and 60? Yes, the highest common factor is 12, exactly. So 12 times 3, this is 12 times 3, and the 60 is 12 times 5. So 3 is one of the perpendicular side and 5 is the hypotenuse. So certainly the other side is going to be 4, right? So that is going to be 12 times 4. So 12 times 4, that is 48. This is the required answer here. And that is the benefit of remembering Pythagorean triplets. Okay. So most of the times we are going to get these basic primitive triplets only. So the smallest one was 3, 4, 5. All its multiples are going to work. Just don't only look for 3, 4, 5. Now, their multiples are also going to work. So we need to see, is there any common factor among the given numbers, and accordingly we can solve. Okay, what about the next primitive triplet? So the next one is 5, 12, 13. Always remember that. Then we have 7, 24, 25. Also after that we have 8, 15, 17, 9, 40, 41. These are some of the few initial Pythagorean triplets. Fine, there are infinite number of primitive triplets. We cannot remember all of them, and it is not required also, but at least remember these initial few ones. How I am saying them initial few ones? I am talking about the value of the smaller, the smallest side length basically. So these are the initial few ones, and it's better if you remember them so that you can directly apply, apply them and solve the question faster. Otherwise, still, if you don't know, then also you can solve this question. You can find out the value of 60 square, you can find out the value of 36 square. It is going to take time, but you can save your time if you know the these Pythagorean triplets. Fine. So these are some of the few initial Pythagorean triplets, primitive triplets, and all of the multiples are also going to work. So you must have all these triplets in your mind. Okay. Let's move further. Now, area of a triangle. How do you find area of a triangle? The basic way is half base into height. Right? So, area of a triangle is half base into height. And I think in between Aditya mentioned there that if bases are given in the ratio 1:2:3, then heights will be in the inverse ratio, because area of a triangle is constant. Astha is asking how to find out these Pythagorean triplets by solving. There are infinite Pythagorean triplets, Astha. They are not following any one particular pattern. There are infinite Pythagorean triplets. And all of those triplets satisfy the Pythagoras theorem. In one of the classes, I remember I told that if the difference between the two longer sides is 1, in that case it appears like, as we wrote earlier, 3, 4, 5. It appears like that this you can see the difference between 4 and 5 is 1 only. So it appears like that this 3 square is equal to 4 plus 5. Same way in 5, 12, 13, the difference between the longer one is 1 only. So it appears that 5 square is equal to 12 plus 13, and so on. But it is not going to be the always. It is not going to be the case always. So no need to create Pythagorean triplets. Important is that you remember at least the few initial ones. That's it. And there are infinitely many other triplets as well. So for every time you are not going to get a simple same pattern. Okay? So this is one method to calculate area of a triangle. Yes, Heron's formula is another one. So Heron's formula is that if we know the three side lengths A, B, and C, so Heron's formula tells us that area of triangle is equal to square root of S minus A into S minus B into S minus C. What is S here? S is known as semi-perimeter. S is semi-perimeter, that is half of the perimeter, A plus C by 2. And remember that using this method, sometimes students do this mistake. They take S to be average. It's not average. It is half of the perimeter, that is A plus B plus C by 2. It is half of the perimeter. Okay, so these are the two major methods to calculate area of a triangle. Sometimes we can find out some more methods as well, but these are two basic ones and most used ones. So certainly we must make use of them. Let's move quickly further. Yes, this is the last part, and we are going to take the question I think Gunjan or someone posted. We are going to end with that question. So what do we mean by similar triangles? What do we mean by similar triangles? So similar triangles are those triangles which appear to be same. If I take photograph of two similar triangles individually, so then it is difficult to distinguish, right? It is difficult to distinguish them. But if the two similar triangles, or maybe of two different sizes, they are kept together, we can identify that one is smaller than one is larger. It may be possible. For example, let me take an example. How many of you have seen Taj Mahal? Have you seen Taj Mahal? Yes, many of you may have. Many of you may have seen Taj Mahal, but have you also seen there are some replicas of Taj Mahal being sold in front of Taj Mahal only, right? A small replicas, small prototypes, models are there. So if that prototype, that model, that small statue of the Taj Mahal, if it is very nicely created, you take a photograph of that prototype Taj Mahal and the actual Taj Mahal. So it would be difficult to identify which one is the real one, which is the real Taj Mahal and which is prototype, because it is exactly similarly formed, right? But what is the difference? The difference is of their actual sizes, the dimensions, right? But what is same thing? The corresponding angles, corresponding shapes, that is exactly same. So basically, what do we mean by similar figures? When the shape is exactly same, but is a difference between the sizes. Right? When the side lengths are proportionately reduced or enlarged. So those figures are known as similar figures. It is not only for triangles, it can be extended to anything. We have just done this with Taj Mahal, right? So it can be in 3D object, it can be any 2D object. But right now our focus is specifically for triangles. So So in case of triangles, for example, if I take a larger equilateral triangle and if I take a smaller equilateral triangle, so both of they are similar triangles. Is it fine? Is it understood? If you understand this thing, yes, same proportion. If you understand this thing, what is the meaning of similar triangles? What is the meaning of similarity? Then you're not going to commit any error. And similarity is the most important concept in the case of triangles. It is the most important concept. So in case of similar triangles, what is same? The angles are same. The angles are same. And what about the side lengths? Side lengths are proportional. Sides are in same ratio. Same ratio, right? The corresponding sides are basically in same ratio. So these are the only two important things here. If you are familiar with them, if you understand that thing carefully, then there is no difficulty at all. ठीक है ना? The sides are in same ratio. That means if this is 2, 2, 2, that ratio is 1:1:1. The ratio is 1:1:1 here also. ठीक है? The ratios are same. But is it mean कि side lengths are same? It may not be. It may be also, but it is not necessary. But the corresponding sides ratio is same. Sides are in same ratio. Okay, is it for only equilateral triangle? No. Let me take any scalene triangle. Let's say all the three side lengths are different here. Okay, let's assume this side length to be maybe 2, this side length to be let's say 3, and this side length is maybe 4. Okay, this side length is 4. Now this is a scalene triangle. Now if I draw a line parallel to this baseline from the midpoint of this side, say. Now, please see this triangle at the top, and this complete triangle. I have drawn this line parallel to the base. Now, are these two triangles similar? How to identify? By angles, whether angles are same or not. Yes, angles are same. Kaise pata? Because lines are parallel, so these two angles are going to be corresponding angles. They are equal. Same way, these two angles are also going to be corresponding angles. They are also equal. And this angle was the common among the shorter triangle and the larger triangle. Is it not? So it confirms that triangles are similar, which means that the three side lengths are also going to be in the same ratio. Same ratio. ठीक है ना? Okay, I took this to be the midpoint of this side. That means how much is this length? Please tell me. I took this to be the midpoint. So what is this length? Please write in the comments fast. What is this length? It is 1. ठीक है ना? It is 1 because this total length was 2, and if this is the midpoint, this is going to be 1. Fine. Okay, what about this dotted side length? What about this dotted side length? This dotted length, which is parallel to this base, it is also going to be half of this, right? Correspondingly, because this was 2 and half of it is 1, and same way this corresponding length was 4 and its half would be 2. So this length is going to be 2. And same way this side length, there's the remaining third side length of the shorter triangle, it is going to be half of this 3, that is 1.5. ठीक है ना? Is it okay? Is it clear? So basically, corresponding sides are in the same ratio. What do we mean by the corresponding sides? Corresponding side means the sides which are opposite to same angles. So as I said, these two angles are same. So opposite to this angle in this larger triangle, we had side length 3, and opposite to this same angle in this shorter triangle, there would be side length which is half of this earlier one. Why? Because this original one was half. So all sides will be in the same ratio. Same way, this was the common angle. So the, opposite to this common angle in the original triangle, the larger triangle, the side length was 4. So in the shorter triangle, this is going to be half. So all sides are correspondingly in the same ratio, same proportion. ठीक है ना? Okay, now tell me one thing. What about the area of these two? If I shade this triangle, can you tell me something about the ratio of the area of these two triangles? What about ratio of the areas? See, base is in the ratio 1:2. All the sides are in the ratio 1:2. So what about the height? So this height is also going to be in the ratio 1:2. If for the entire triangle the height was h, so this height for the smaller triangle is also going to be half of it. It is in the same ratio. ठीक है ना? So how to find area? We just discussed in the previous slide, half base into height. So it is going to be half base into height for the smaller triangle and half base into height for the larger triangle. ठीक है ना? Now half is the common part. So ratio of bases is 1/2 and ratio of heights is also 1/2. So the ratio of areas become half ka square, that is 1/4 in this case. So that's how ratio of n areas of any similar figures become square of the ratio of corresponding sides, because two corresponding dimensions are to be multiplied. In this case, we have multiplied base and height. You can use any method to calculate area of triangle. Ultimately, you are going to multiply two linear dimensions. That's why the ratio of areas of similar figures is always going to be square of the ratio of corresponding sides. ठीक है ना? Okay, let's solve the last question here. There is similarity in right angle triangles. So yes, this is the last question. Please solve it. I think this is the same question Gunjan was asking. Are you here? Let's draw the diagram at least. In a triangle ABC, AD and BE are altitudes. Let me draw the diagram for you. So there is a triangle, let's say something like this. Okay, this is a triangle. Let's call it ABC. Fine. Now it says AD and BE are altitudes. So AD is altitude. So from A, I need to drop a perpendicular. This is a perpendicular here, AD, and BE. From B also, I'm dropping perpendicular on AC. So this is BE. So both are altitudes. So this angle is 90 degree. Fine. And EC is 5. So EC is this length. It is 5. Okay. CD is 6. So this length CD is 6. AE is 3. So this one is 3. Question is find the length BC. So this complete length is to be determined. This complete length is to be determined. So that is the question. Take 1 or 2 minutes. First, I'm giving a chance to you. Please solve it. Answer it fast. This is the last question for the day. We shall end with this. Please answer this question fast. Karthik, Rakesh say 12. 12. Okay. This is a very easy question, not difficult. Prakhar, the length of BC is being asked. So BC is certainly more than 6. Now, how it can be 3? It is certainly going to be more than 6 because it is 6 plus something. Are you assuming this D to be midpoint? It is not mentioned. Why do you assume so? Don't assume that. How did you solve it, Karthik, Rakesh, or Petrus? How did you get this length BC? BD6 कैसे आया? Okay, let me ask you something. If I call this angle to be theta, so in triangle BEC, this is theta, this is 90. So this is going to be 90 minus theta. Fine. This is going to be 90 minus theta. And in this triangle CDA, Megamix says 20/3. I don't think so. Let's check. So in triangle CDE, this angle is 90 minus theta. This is 90 because this was altitude. So what about angle at vertex A? Isn't it same theta? Yes. So do you see two similar triangles here? Yes, this triangle BEC, let me write, this triangle BEC is similar. If BEC, we have the angles theta 90, 90 minus theta. Now in this triangle, again we have theta 90, 90 minus theta. That is triangle ADC. This is similar to triangle ADC. Yes or no? Fine. So these two triangles are similar. So corresponding sides are going to be in same ratio. That's it. So what side length are we aware about? First, let me write what sides are going to be in same ratio. So BE is corresponding to AD. So whatever is the ratio of BE upon AD, it is going to be same for EC is to DC. EC upon DC, and also it is going to be same for BC and AC. Okay. So whatever side lengths do we know, let's write and then see what can we do. So BE मालूम है क्या? नहीं, BE तो मालूम नहीं है. AD is also unknown. So let's leave them. It's not required. Let's focus on these two parts only. EC do we know? Yes, EC is 5. And what about the DC? DC is 6. This 5 upon 6 is equal to, here BC is what we want to find out. And what about AC? AC is 8. ठीक है ना? We are done. We are done. So just simplify it. So what you are going to get? So this BC comes out to be 5 into 8 by 6. So what you can cancel out? So 2 is a common factor. So 2 3s are 6, 2 4s are 8. Yes, 20 by 3 is correct. ठीक है. This 20 by 3 is the right answer. Root कहाँ से आ गया प्रखर? Yes, all the three angles are same. That's it. That was the condition. Is it fine? Some of you have got different answer. Let me check. Did I commit any error somewhere? Theta opposite 6. कहीं मिस्टेक किया क्या कुछ? BE upon AD would be equal to EC upon DC equal to BC upon AC. ठीक है? And EC is 5. EC was 5, right? And DC was 6. That's it. So 5 upon 6 is equal to BC upon AC. Now AC was given 8. ठीक है? So 20 by 3 is the right answer. Fine. Okay, so we shall end it here. Thank you very much. And I hope whatever methods, whatever things we have discussed and whatever properties we have discussed, so you will certainly follow that. You will certainly make good use of that and be progressive in your preparation. Fine. So I thank you very much and congratulate all of you. And that's it for the time being. So good night, all of you. Thank you very much again. Thank you. Urushi, yes, the triangles are similar because of the equal angles. And that has been mentioned by Megomik. Thank you, Megomik. Okay, so I will request all of you, please practice questions as much as possible from all the material which you have received and also the previous year's CAT questions. That is certainly going to be very, very helpful. Okay, I shall take your leave now. It's already at least 15-20 minutes late. So I shall take your leave. I am ending this stream. Thank you once again, all of you. Thank you for joining.